Hey everybody, this is Brian Sam-Bodden. Welcome to Extending Redis with Rust. I am a developer advocate with Redis, and you can reach me at bsb@redis.com, on Twitter at bsbodden, and you can also check out my GitHub repos. So Redis. Redis is a popular data platform that it's mostly known as a very powerful and fast cache. But Redis is much more than that. So today I want to give you a quick tour of Redis before we look at how to extend Redis for your own benefit. So Redis stands for Remote Dictionary Server. In Redis, it's really an in-memory first full-blown database with optional persistence. Out of the box, Redis provides many data types. And Redis is classified as a key value database. But the difference between Redis and most key value databases or key value stores, it's that the value part in Redis can be anything you can dream of. Out of the box, you get strings, bitmaps, bit fields, hashes, lists, sets, sorted sets, geospatial indexes, hyperlog logs, funny name, and streams. But there's more. And those are all the values that can be addressed as using a key in Redis. But like I said, there's much more than that. You can extend Redis by adding new data types and new commands to manipulate those data types. Ourselves, as a company, we promote 7 different modules that extend Redis with new data types and commands. Those are Redis JSON, Redis Search, Redis Graph, Time Series, AI, Gears, and Bloom. And they extend Redis to basically behave like a document database, a full-blown search engine, a graph database, etc. And now for a quick tour of Redis. So before we get started with our module building, let's take a quick tour of Redis by starting a Redis server. And I'm running Redis 7.0.4, which is running on port 6379, which is the default Redis port. And on a separate terminal, I'm going to start the Redis CLI, which is the command line interface for Redis. And by default, it connects to the localhost 6379. So one of the basic data types, or the most basic data type that you can keep in Redis, it's a string. And that is the basic level key that you have in Redis. So I'm going to create a key called actor:001 and give it the value Cubby Smolders. Now in Redis, it's very typical to create your own namespace for your keys by using a separator like the column in my case. So I can retrieve my key back from Redis, and it gives me the string that I set, Cubby Smolders. And I can also inspect a key to see what value it's holding. In this case, it's a string. Let's set another key here, actor:002. And let's make this one Karen Gillen. As you can see, I'm using Marvel characters in here. And again, I can retrieve the value of that key. And if, for example, I try to retrieve a value of a key that doesn't exist, I get a nil back. And you can also set, for example, encoded strings, escape strings. Pretty much any binary piece of data can be stored in a Redis key. So I can say get actor:003, and you can see my wonderful misspelling of Benedict Cumberbatch's name. You can see here that I can also pass, for example, I can set a key passing the NX flag. That basically means set it if it doesn't exist. So in our case, that's going to be have no effect on the original set value. But if I pass the XX flag, then it will overwrite the value that was there before. So in Redis, I can list all the keys by passing the keys command in a star. And that's obviously not recommended in production since Redis is meant to hold millions or billions of keys. But it's okay in a debugging session like this. So I can also delete a key. And I can check if a key exists in the system. All right, so that is the most basic data type in Redis. We also have hashes. In hashes, it's the very typical data type used for mapping programming language constructs like structs or classes, objects to Redis. So in this example, I'm going to use the hmset command, which sets multiple values on a hash. And I'm going to use the actor001 key. So I'm going to override the key that we had in there. And I'm going to pass a name value pairs for an actor. And in this case, I'm passing the name Anthony Mackie, year of birth 1978, place of birth New Orleans, USA. All right, so I can now check my keys again. And I can do an hgetAll, so get me all the name value pairs from a hash, actor001. And you can see that I get my name value pairs back out. Hashes are kind of the workhorse of Redis. So for example, I can say h exists, actor001, and pass the string character, and it will tell me whether that hash has been set, that value has been set in that hash. So for example, now let's go ahead and set that individual value. So I'm doing a hmset actor001, passing the character key and the falcon value, or falcon as the value. And now if I check again for existence of that flag, of that field, you can see that I get a 1 instead of a 0. And once again, I can do an getAll for that key, and I get all my values back. So knowing those two specific data types, it's all we need for our purposes today. Okay, so let's talk about the Redis Modules API. In the Redis Modules API allows you to extend the functionality of Redis by adding new data types or adding new commands. Until recently, the Redis Modules API was only available to C programmers. But luckily for us, in the last couple of years, Redis has been developing a Redis Modules API bridge in Rust. And why Rust? Because it shares the philosophy of extreme carefulness in memory management and performance. Redis modules run in the same memory space as Redis. Therefore, any memory leak can compromise the health of the Redis server and create a catastrophic condition for the server. So safe memory management, it's a must in Redis modules. There is a Rust crate that wraps our Redis modules API bridge, and you can find that on crates.io. And we're going to be using that today to build our demo. We're going to create a finite state machine as a Redis module that's going to be in charge of managing state in Redis hashes. And we're going to name it Redis FSM, and we're going to use the Redis modules crate that we've shown previously. So the finite state machine, it's an entity that models and controls behavior for an entity. So we define a set of possible states, the transitions between those states, and the events that trigger those transitions. And why are we targeting Redis hashes? Because Redis hashes are typically used to map objects from a programming language into Redis if you're using Redis for persistence. So our Redis FSM module will store a generic FSM definition that we would initially create as JSON and then stored as a specific Redis data type. The definition will contain the set of states, which type of hashes it applies to by their prefix, the name of the field that will be used to persist the state into the hashes, and the possible transitions and events. So imagine this simple state machine. We're going to be using the same one during the demos. We have 3 states, sleeping, running, and cleaning. And notice that the events in green allow you to transition from a state to another. So for example, from sleeping to running, the run event triggers that transition. From running back to sleeping, the sleep event triggers a transition. From cleaning to sleeping, the sleep event also triggers a transition. And from running to cleaning, the clean event triggers that transition. So here is a bigger picture of the scheme that we're setting up in here. So we have a definition of a state machine on the top left corner, which we're going to represent as JSON. That JSON is going to be turned into a binary Redis type that's going to be stored by the module in Redis. And we're going to have two commands on the left, FSM create to create our finite state machine data type in Redis, and a FSM info to read it back as JSON again. Then we're going to have two commands to basically do most of the interaction with the state machine and the hashes that the state machine applies to. One of them is going to be FSM allowed, which is going to interrogate a state machine hash combination, whether a specific event can be applied to the system, and one that actually applies the event, which would be FSM trigger. And then there will also be an implied event transition or initial state setting that will be done when a new hash is saved in the system, into Redis, and our module is going to detect that the state field is not in there and set the initial state of the hash. So that way we have the beginning of our state machine functionality. So in our case of the example on screen, it would be the sleeping state. So if a hash is saved to the system and the sleeping state is not set, or the state field is not set, then we set it to sleeping. And here's the JSON document for our sample FSM definition. All right, so we're going to kick off our demo by creating a new library using the cargo new command. We're going to pass the lib flag. I'm going to name my library Redis FSM for Redis Finite State Machine. And I'm going to put it in a folder called Redis FSM, all in camel case. As you can see, we have the output of the library being created. And let's cd to that folder and use the tree command to quickly inspect what we have. So we have a cargo toml file and we have a lib.rs file. Let's quickly take a look at those. I'm going to inspect the cargo toml, and we just have our package declaration for Redis FSM. And let's do the same thing with the library file. And in that one, we have a simple function to add two unsigned integers, and we have a simple test. And we're going to get rid of that, but that's a good skeleton to get started. All right, so with our newly created library loaded in the code editor, we're going to open the cargo toml, which I already have open in here, and we're going to add the dependencies for the Redis Module toolkit. We are also going to set the crate type to cdylib, so we can create a dynamic system library to be loaded in Redis as a module. First, we'll tackle the FSM create command. I'm going to open the Rust code in librs. And in there, you can see that I already have the extern create Redis module being used. And we're going to import from Redis module a few structs, enums, and types that we're going to be using down in the code. And our first skeleton code is going to be a function called FSM create. And this is going to be the function that backs up the fsm.create command that we will be creating. And as you can see, it takes a context. The context is going to be a Redis context. It's going to be passed to us by the modules API. And then we get a vector of arguments, which are packaged as Redis strings in the args argument. And each one of our module methods or our module functions returns a Redis result. So inside of this, we're going to skip the first argument. The first argument is going to always be the command itself, so we want to ignore that. And we're going to grab the length of the arguments in here just to do a quick check. So it's if the arguments arity it's greater than what you're expecting, you throw a Redis error. Then I'm going to grab the actual argument that's being passed, and I'm going to call that source, src. And I'm doing that by using the into iter. And then I'm going to use the next string, which is going to return a string object. Next, I'm going to take that source and I'm going to format it in a string with the format macro. And I'm going to call that greet. So this is going to be our hello world example. So we're going to do this in the skeleton of this function so we can see how things work, and then we'll get into the more meaty stuff. All right, so now I'm going to create a response, and my response is going to be a vector from that greet string. And then we're going to wrap that whole thing into an OK. So we're going to be using the Redis underscore module macro, which is going to be the block of code that's going to basically declare the module to Redis. So inside of that, we're going to have the name of our module, which is going to be FSM for Finite State Machine. And then we're going to give it a version of 1. Right now, we have no data types. So we have a block for our commands. And inside of that, we're going to add our FSM create command. So notice that the name in the string, the first element in here, fsm.create, is going to be the actual command that you type in the Redis CLI or that you send with a Redis client. And then it's going to be backed by our FSM_create function above. All right, so now that we have a basic hello world implementation inside of our FSM create command, let's start the Redis server and load our newly created module. So before we do that, we need to compile the module. So I'm going to do a cargo build. And now we have the module has been compiled. It will be under the target debug folder. And you can see there that we have the lib redis underscore fsm dylib file. So now to load that into our Redis server, I'm going to invoke the Redis server command again. And this time I'm going to pass a load module flag in the lib redis fsm file. So target debug lib redis fsm dylib. All right, so now we have the Redis server running. And as you can see on the output, we have loaded the FSM module from the dylib file. All right, so now with that in place, let's launch the Redis CLI. And in the Redis CLI, one of the things we can do to verify to you that the module has been loaded is to do a module list. And you can see that we have only one module loaded in this instance of Redis, mainly the FSM module that we just created. All right, and the Redis CLI kind of auto-completes commands. So if we do FSM, the only command loaded right now is FSM create, and we can pass a string to it. And as you can see, we get the hello back. Notice that the emoji that we had in the code, it's actually encoded in the string. So I kind of wanted to show you that Redis basically stores everything in raw format. So now we see that we have a working command, very simple command, doesn't do anything. Now let's go back and flesh it out. So the first thing I'm going to do is bring in the inserted JSON dependencies, because we're going to be using JSON. And now back to the code, the first thing we're going to do is add a state machine struct. And as you can see here, I have a state machine that has a name, a prefix, a field, in a set of states. To transition from state to state, we need to have the definition of an event. So I'm going to create a struct that basically represents an event, and the events will have a name, and it would have a state that they can transition to, and also a collection of states that they can transition from. So we have an event. In the state machine, we're going to add a vector of events. Now that we have our data structures for the state machine, the next thing we're going to do is add a few definitions that we're going to use to basically manage the registration of our state machine data type. Okay, so let me show you what we have in here. The first one is this Redis FSM type name. That's going to be the name of the type in Redis. And that has to be 1, 2, 3, 4, 5, 6, 7, 8, 9 characters specifically. It's one of the requirements of a Redis data type that has to be exactly 9 characters. So we're calling ours Redis-FSM. The version of our data type, it's version number 1. You can basically have multiple versions, and then in your code, you would basically have to manage backwards compatibility with older versions of your data types, if you choose to do so. Then the actual type will be created under the Redis FSM type. And then this is a Redis type. Notice here we're invoking the new function, and it takes the type name and the version, and then a set of methods that basically initialize or manage how the data type lifecycle is handled by Redis. So now we're going to make some modifications to our FSM create. And the first thing that I'm doing in here is that I've added this line right here that creates a variable called Redis key, which it's actually grabbing the context. Notice that I brought the context variable back into scope, and that context provides an open key writable method. And that method basically takes a key definition, a Redis key, and it's going to basically give us a slot in Redis to write something to it. So then once we have that, we're going to create some JSON representation, a strict representation of our state machine. So notice that we have a JSON document here that has the name, prefix, field, the states for our state machine, and definition of events. In this case, we have that simple state machine that we've shown in the slides before, which has 3 states, sleeping, running, and cleaning. And it has 3 events, run, clean, and sleep. And remember, run can transition from sleeping to running, clean from running to cleaning, and sleep from either running or cleaning to sleeping. Right, and notice that I'm using the JSON macro from Certa to basically create a JSON object. And then once we have our JSON object, we're going to serialize, we're going to create a state machine from that JSON object. So notice in here, I'm using the Certa from the string of the JSON that we created, and that is going to give me an instance of our state machine struct. So next, once we have a state machine object, we're going to use the Redis key to write that value to the Redis key, passing the specific type that we're writing, which is our Redis FSM type, which we declared up here in that Redis type block. Okay, so we wrote the key to Redis, and now we're going to get rid of that hello world part of the example, and we're going to return a Boolean as an integer, true if we were successful at writing that Redis value to Redis, that key value, the actual serialization of our state machine, and false otherwise. Right, so that gives us now the ability to write our custom data type to Redis. We also need to add the Redis type to the module declaration. So notice in here that under the data types vector, I added the Redis FSM type. And we're also, now that the FSM create, it's right into Redis, we actually mark it with the modifier write, telling us that this command writes to the database. And the three ones at the end in here represent the index of the first key, the key step, and the index of the last key. So since we only have one parameter, the main key, one key actually, we have one across the board. Now we will build the FSM info command. Okay, so now that we have a method that can write our custom data type to Redis, we should probably add a method to read it back. So for that, we're going to implement the FSM info method. And the first thing I'm going to do is just add a skeleton for it. Just like the FSM create method, our FSM info again takes a context, a set of Redis arguments, Redis strings, and returns a result. We're starting with just a result okay with a null value. And now we're going to grab the arguments like we did before, and we're grabbing what's supposed to be the key as the first argument after the method name. And then we're going to again create a key, but this time we're going to open our key similar to what we did in the FSM create. So notice in here, I did a context open key writable. And in the FSM info, since I'm only reading, I just did a context open key, passing that key value. Then I'm going to bring in the guard crate so I can avoid having to have nested let in my code. So this is going to allow me to write a little bit cleaner code in my opinion. So with that in place, I'm going to create this guard where I'm basically trying to bring the state machine back from the JSON that's stored in the database in Redis. So notice in here that I'm doing a guard and then a let okay. So that's going to be the Redis response. So I want it to be a successful response that contains some object of type called FSM, or that I'm going to name FSM. And I get that from reading the value, casting it to a state machine using my Redis FSM type that we declared previously. And if that fails, then I'm just going to return an error with a Redis error that contains an error message. And very likely it's the errors that I couldn't find the key. Now with that in place, I'm going to use Survey again to basically put the JSON back into string form and return that JSON wrapped in a Redis value simple string with an okay around it. So with that in place, we need to add the command to our declaration like we did before with the FSM create. So in here, I'm going to now add the FSM info. And again, we have the FSM info command being backed by the FSM info function. This one is a read only. The other one was a write. And again, since we only have one key and it's the first key, we have ones across the board here in the definition. And now we can go and test this. Okay, so now that we have our two commands, the FSM create to write the JSON definition of the state machine to Redis and the FSM info to read it back, let's compile our library again, our module, and let's launch the Redis server again, loading our module. All right, and now, again, let's go back to the Redis CLI. And let's see what keys we have in the system. It should be empty again. All right, so now we can do an FSM create. And in here, I'm going to pass the key is going to be job FSM, which is kind of what we hard-coded in the JSON for now. So if I do that, notice that we get a 1 back. So that means that something went right. And now I'm going to list the keys again. And notice that we have now one key, job FSM. And if I check the type of that key, we get our custom Redis data type, Redis-FSM. So now let's see if our Redis command FSM info works correctly. So I can pass the key that we just created, and we get our XML back. In the Redis CLI doesn't pre-print the XML, so you could use Redis Insight, for example, if you wanted to basically see a nicely colorized version of the JSON definition. So now we have a command. We have a data type that represents our finite state machine, and we have a command to create it and one to read it back. Okay, so now we have two commands, one that writes some JSON definition of an object, and one that reads the definition. In our lingua franca to store them, it's JSON. So now what I'm going to do is now refactor that FSM create, so we don't hard code the JSON, because we really want to have the flexibility to have multiple state machine definitions there. So the first thing I'm going to do, it's rather than just reading a key, we're going to take the JSON. So I rename the first argument being read to FSM_JSON. And then I added this block in here where I'm taking that JSON, that raw JSON that it's being passed from the command, and we're going to use the third JSON library to read it from a string, the toString of that FSM JSON, which is a Redis string, and that's going to give us our state machine object back rehydrated. And once again, now the key to write this to Redis is going to be the name property in the JSON. So what I'm doing in here is I'm taking the FSM instance that we just created from the JSON and grabbing the name to basically create our Redis key. Okay, so now we can test our refactor version of the FSM create method. So once again, I'm going to compile our library, and I'm going to launch the Redis server, and also run the CLI. And now our FSM create method, obviously it's a much more beefy method, because now it takes the JSON payload. And obviously I have it ready here to copy and paste. Notice that the JSON has to be escaped properly. So all the internal quotes have to be escaped with the backslash. And when you have large payloads to load in the CLI, rather than pasting them into the CLI, you can actually pull them from an external file. But since this is a quick and dirty example, I'm just pasting it on the CLI. And if you have it in a file, you don't have to do all this escaping maneuvering here. So I'm going to run my FSM create now with the JSON being passed from the CLI. And again, we can check once again that we have our key being created, and that we can read it. So now we have a full round trip with a custom definition of our state machine. Okay, so now we're going to implement the actual functionality of our state machine. And one of the first things that we want to do is when a new hash matching the given prefix it's added to Redis, we want to intercept that and set the initial state field given a state machine that matches the prefix of the hash. So to do that, first I'm going to add a function called onEvent, and this onEvent function takes a context again, but this time it takes an event type, which is a notify event, and the actual event as a string and the key as a string. And inside of it, for now, we're just going to have a message that basically prints what the event was in the key in the event. So the event type, the key, and the actual event. And we're going to log that to the context with the log notice login message. So once we have that in place, we have to register that event. So down in our Redis module registration block, we add an event handlers vector that has inside a event handler of type hash, and we're pointing that to our onEvent function. So when a hash event is detected, we're going to get notified, and our onEvent function is going to be invoked. All right, so with that in place, we can now test the event functionality. All right, so now let's compile our library again, and let's launch it. And let's launch the CLI. Let's up arrow so we can get to that FSM create. So we'll create our FSM, our job FSM finite state machine. Let's make sure that the key is there. Again, let's make sure that we can read it back. So it's job FSM. All right, so now what we're gonna do is, let's do an HM set. So we're gonna create a key. We're gonna create a hash, and we're gonna use the prefix that we're listening for in our state machine. It doesn't really matter right now, but it will once we actually look for that prefix. But for now, any hash event should be detected by our event handler. So in here, I'm gonna create this hash called job001, and let's give it a feel here, maybe employee, and this is gonna be Brian. Okay, so now pay attention to the Redis server tab. So I'm gonna press return in here, and notice that this is spinning because now we just receive our event. So in here we have received event hash on key job001 via the event hset. So our event was a hset event. So that was the command that basically was triggered by the hm set. So each one of the writes to the hash, it's an hset event. And in here I get the key of the hash that was created, and the event type was a hash. All right. All right, so now we got a big refactoring in our hands. We need to implement the onEvent function. So when a hash event arrives for a hash that has a key with a prefix matching any of the prefixes defined on any of the FSMs that we have stored in the system, we want to then check that hash. And if the state field is empty on that hash, we're going to grab the initial state from the state machine that matches that prefix for that hash, and we're going to set it up on the hash. So to do that, first we're going to start by grabbing the prefix for the hash for which we have received an event. So I'm going to split the keys by the column, and then I'm going to grab the prefix as the first segment of that list of key parts. And I'm going to reappend the column in there to build my key prefix. So then, if we go back to the FSM create, we're going to now, we need to basically have a way for given a hash prefix, be able to find the FSM that matches that prefix. So there's many ways we can actually store that data. So we basically need a dictionary or a hash or a map between prefixes and finite state machines. And the way that I decided to implement it in this demo is to actually use Redis itself. So I'm going to use a Redis hash to store a mapping of prefixes to the keys of our FSMs. So we're going to start here by refactoring this. So we were returning just a result of setting the value of the FSM when we wrote it to the database. Now we're just going to put that in an individual line with one of these guards. And in here's where I'm basically writing my state machine, my serialized state machine to the system. And then in between that and the return, first I'm going to create a constant that basically tells me the name of the hash where I'm going to keep my mappings. My mappings between, again, prefixes to FSM keys. So now I have that hash name that we're going to use. And down below here, notice that I'm using the context to call hset. So this hset, it's just a command, a Redis command, and the Redis context gives us access to those commands. So I'm going to call the hset command, and I'm going to write to this Redis FSM hash key that we created here. And I'm going to write the prefix that is defined in the finite state machine JSON. And I'm going to write also the key of my finite state machine as the value in there. So now with that in place, I can now make some modifications. So now we have a set that has those values. So let's go back to our on event. And in here, notice that now I can find the correct finite state machine for the key prefix. So what I'm doing in here, it's again, I'm using a guard again, and I'm looking for my FSM key by calling hget. So we did an hset to save the mapping upon creation of the state machine. And now when we get an event for a hash, we're going to use hget to look into that map to see if our event prefix, our hash prefix, matches any of the prefixes of our state machines. I'm also assuming that the prefixes are unique per state machine. So now with that in place, I can now create a key name, which is going to be, I'm using the context in my finite state machine key. And I am basically opening that key. So I'm reading the FSM back. And then from the FSM here, which is basically my instance of the finite state machine, which is going to be the struct that we defined before. So it's going to be one of these. So that state machine object now, it's loaded here at the end of the current implementation of our own event. So once I have the state machine object, I can grab the initial state, but I'm only going to grab the initial state if a call to trying to retrieve the FSM field from the hash comes back null. So that means if the hash doesn't have the state field set, I'm going to initialize it to the initial value that is on the state machine. So notice in here, one of the things I need to do is I need to have a way to retrieve that initial state. So how do I retrieve that initial state? That's going to be, if you remember our JSON object or the definition. So let's go back here to our state machine. This set of states, the first element of this vector is going to be our initial state. So now let's add some logic to our state machine. So I'm going to add an import block for our state machine in here. And we're going to create a initial state field. So our initial state, this being a method, takes a pointer to self, and we're going to return an optional string. So that means if there are any states in here, we're going to return the first one or none. And with that in place, we can now go back to our on-event implementation. So back here on the on-event implementation, now we can call that new method that we created on the state machine struct. So we're going to basically use a guard again, and I'm going to attempt to grab the initial state by calling the initial state on the FSM object that we retrieved up here. So once I have that, now I can call an hset. So I did an hget to find the correct mapping of prefix to state machine. Then I instantiated that state machine. If the field also was empty, I used another hget to check if the state was set on the hash. And if it wasn't set, now I can grab the initial state from the state machine and do another hset on the hash, on the incoming hash, on the field that was defined on the state machine as being the initial state, and grabbing the initial state value from the state machine. So now with that in place, we should have a fully functioning step of the state machine that sets up the initial state on any matching hash. Okay, so let's build the application again, and let's launch it so we can test our event handling code. So back on the CLI, let's reload our finite state machine JSON, and let's do all the usual checking. So let's actually inspect the hash of mappings. So we'll do an hget all for redis-fsm-hash. And you can see that we have the job prefix that we set on our JSON specification, and it maps to the key for the FSM that we have in the system. So now let's do an HM set for a key matching our prefix. So again, let's do job 001, and we're going to say again, employee Brian. And as you can see, the Redis server detected the event. Notice that we have two events, one on the Redis hash, but that one doesn't match our prefix. The Redis hash that keeps the mapping of prefixes to FSMs, and then for the actual data one, the job 001. So now let's inspect the values. So we'll do an hget all for our job 001. And as you can see, now we have the initial fields that we set, employee Brian, but we also have the state set to sleeping. And if you remember, in our FSM definition, our first state is sleeping, which is our initial state. So our state machine initial state setting on events works. Now we can move on to implement the FSM allowed command. Okay, so now we're going to implement the method that allows us to check whether an event can be applied to an object to transition to a different state. And to do that, first we're going to create a skeleton for the FSM allowed method function, and has the same signature as the methods before. And we are also going to register that command in our Redis module command declaration, module declaration. So I have my FSM allowed. It's going to be backed by that FSM allowed function that we created above. And again, it's going to be a read-only. The first key parameter, it's a parameter in position 1, but this one takes 2 keys. So the first key would be the key of the FSM, of the final state machine. And then the second key would be a target hash for which we are checking whether an event can be applied to. All right, so now we're going to add a method to our final state machine struct. So let's go find the final state machine, the finite state machine. And yeah, so we have here in our import block, we're going to add a method called allowed. And this one is going to return an event. And this event is going to be one of our event substructs. This one right here, the event that basically denotes an event that can be applied to the state machine, which will basically transition from a state in the from vector to the final state denoted by the to field. Right, so in our function, right now we're returning none. So the first thing we're gonna do is load the hash that basically we're checking against. In that hash, we're only interested in the state field. So we're using the finite state machine field, which remember it's in our declaration right here, to basically look for that specific state in that target hash. And if we find that state, that's going to be in response. So we're going to grab the value of that, which is going to be a Redis value simple string. And we're going to put that value in the current state. And assuming that we can get that value out, then we're going to find the event object, the event struct that it's inside of our final state machine by iterating over the events, and going to find the event with the name that matches the FSM event value that's being passed to us. So this is the event that we're checking whether that hash can transition to. Right, so if we find that event, it's going to be in our event object. And then if the current state of the from field, so if the current state of the hash, it's one of the values in the event, from vector, then we know that we can transition to the final state denoted by that event. So if that's the case, we can basically return that event. Otherwise, we return none. And now if we go back to the FSM allowed method, here we go. Now we can refactor this to extract the keys. So I'm going to extract the final state machine key as the first key. Then the next key would be the hash key. We're also loading our Redis key so we can read the final state machine value. And the event would be the next argument. So remember, there's only two keys. So there's the final state machine key, the hash key, and then the target event. So that's why we only have two keys denoted in our declaration down here. So that 2 means that there's two keys. Even though we have 3 parameters, the third parameter, it's the event that we're checking against. All right, so back to the FSM allowed. Let's finish that implementation. So in here, I'm going to have that guard again, where I extract the final state machine object by reading it from Redis, given its key. And then now that I have the final state machine, I can call the final state machine allowed method that we just implemented above, passing the context, since we're going to use that to basically read things from Redis, the hash key, and the event. And then if I get an event back, that means that we're good. So I don't need the event object in this specific method, but then I'm going to use it to determine whether to return true or false right here. So now let's restart, let's recompile the code. And let's restart our server loading our module. And then back on the CLI, let's up arrow here to recreate what we've done before. We're going to load the FSM. And let's set a hash. Again, let's use the job 001 with employee Brian. Again, let's double check that our initial state has been set on the hash. You can see that the state is sleeping. So now I'm going to do an FSM, and this is going to be allowed. So notice that the CLI auto-completes that. And the first key we're going to pass here, it's our job FSM. And then the second one, it's going to be the hash, which is job 001. And then the let's test one of the events. So one of the events that we have in our final state machine, it's sleep. So sleep can transition from running or cleaning. So let's try that one. Since we are not on running or cleaning, we're sleeping, we return false because we cannot transition using sleep. So the sleep event is not allowed in this specific case. But running can also, the event run can transition from sleeping to running. So let's see if run, it's allowed. And as you can see, run, it is allowed. All right, so now we have a way to check whether an event can be applied to a given hash. Finally, we can implement the FSM trigger command. All right, so now we actually are only missing the command that would allow us to actually transition a hash from one event to the other. So we have one to ask whether a transition or an event can be applied to a hash. And now we're going to have one that actually triggers that event. So to do that, we're going to create a skeleton method for our new command. And this is going to be FSM trigger. We're grabbing basically the same arguments that we were grabbing with FSM allowed. So this whole block here, it's identical. We again are grabbing the state machine, and this one is again going to return a Boolean. So to actually do this, we now need to, as we did before, implement a method in our final state machine, finite state machine struct. So let's find our implementation up here. Okay, so we have there the allowed method that we implemented earlier. And now we're going to create a trigger method. And the trigger method, the implementation, it's very similar, and it actually reuses the allowed method. So notice in here that, again, I am grabbing the key of the hash that I'm interested in applying an event against. And then I am going to grab the event only. Remember that we set allowed to return the event that you need to use for that specific current event. And I use the allowed method above to grab that event, passing the context, the key of the final state machine, and the of the hash and the event. And then I'm going to now call hset on the target hash, and I'm going to set the event field or the state field to the event that they're interested in. And again, I have this guard right here that basically it's asking whether the event is allowed by using the allowed method. And if it's so, I then change the value of that field on the hash. Then I basically just return to the caller if I get an okay response. So now, once we have that trigger implemented in there, in the final state machine, we can go back to our FSM trigger skeleton and finish the implementation in here by simply having an allowed variable that calls the trigger method in the finite state machine struct. And I use that to return that Boolean as an integer in my Redis value response, Redis result. So with that in place, then all we have left to do is register our method. So now I'm registering the trigger method with the Redis module macro commands list. And again, this one, it's just like FSM create, it's a write method. And it takes the first key, it's the key in position 1. Position 0, remember, is just the command itself. And it has 2 keys, the final state machine and the hash. So now with that in place, we can test again. So, okay, now we have completed the basic implementation of our toy state machine. So let's go ahead and compile the code again. And I'm going to launch the Redis server. And then once again, let's get to the CLI and up arrow to find our FSM create. And let's just test all of our methods. So when we run FSM create, remember that that creates the job FSM custom data type, which is a finite state machine data type. So when we check the type of it, we get Redis FSM. The Redis FSM hash, once again, it's a native Redis hash where we are keeping our mappings of prefixes or hash prefixes to finite state machine keys. So again, we have for the sample that we've been using, it's a job for the prefix, and that maps to the job FSM key. All right. Remember that we also implemented the info. So we can pass the name of a state machine, and that will basically grab that native data type that's stored in Redis and use JSON, server JSON to convert that to a readable chunk of JSON. And if we create, let's create a hash. Here we go. We create a hash. And now we do an getAll on that hash. We should have our state set to the correct value, which is the initial state of the state machine sleeping. And then remember that we can ask the state machine whether we can transition to the different, using different events. So we can ask whether we can run from sleeping, and it says yes. And what was the other one? The other one was sleep, and that's a no. And so since we know that we are allowed to run, I'm going to trigger the run event on our target hash. And that responded with a true. So now if we do an getAll, remember we were in the state sleeping, and now we are in the state running. So there we go. A simple toy state machine implemented as a Redis module. And of course, all the source code for today's demo can be found under my GitHub repositories. To learn more, visit us at Redis Developer, which is located at developer.redis.com, where we have tons of examples for pretty much every programming language for interesting things you can do with Redis. And also, if you want to learn more about Redis, come to Redis University, where there's a variety of courses that can help you become a Redis expert in no time.